The next thing to think about is the culture of technology, or another way of thinking about that is how we perceive all technological knowledge through cultural lenses that we ultimately use to make sense of our world. Culture greatly impacts the way that we see technology. For example, the Amish see technology in a much different way than the rest of most of American society. The Amish choose to not embrace all of the technological innovations that the outerlying societies that they're embedded in have chosen to actually embrace. And the reason they do that is in reference to how they construct their daily routines and their daily lives, the religious foundation for their belief systems, and how that greatly impacts the way that they see culture, or they see technology playing a role in those routinizations. Um, in this case, and in many cases, technology shapes culture, but culture also shapes technology. The Amish are a much more rudimentary society because of the social and cultural decisions that they've made, versus the societies that surround them that have allowed technology to take a greater role in their daily lives. And we also need to remember that we may invent new technology to fit our new cultural aims. And this is a process where meaning becomes the means. So the meaning of something ultimately results in how we structure our society and the cultural and the technological decisions that we make, that drive that new form of social organization. The politics of technology is another category that we need to think about. Um, this is visible via the active manipulation of markets through lobbying for subsidies. Resistance to technological structures such as environmental justice can also be a result of this process. I talked about the automobile and how lobbyists are continuing to throw around their wealth and influence in the halls of Congress to prevent alternative technological solutions to the way we move ourselves around. Automobiles are so resilient in our daily lives because of political maneuverings that continue these types of subsidies to protect oil-based, automobile-based social forms of organization. Another thing to think about is passive technological politics, where where we're uncritically promoting particular technological structures and social interests. Once again, the automobile is a great example of this when we think about the hidden subsidies that we don't really think about in critical ways. We don't think about the overall impacts the overall negative externalities the automobile brings to our social existence, because the convenience is so warm and fuzzy. Another concept to think about is scientific capital, or scientific capital. Scientific capital gives a scientist a vested interest in protecting the institutions of science for their own advantage. So science is like the science. So for example, before Einstein came out with his very outlier ideas on the theories of relativity, the scientific enterprise itself was very, very resistant to change. Even though science has built within itself the ability to change, it takes a lot of momentum to force science to change ultimately. And so when new ideas like Einstein's ideas on the theories of relativity came out, the scientific enterprise itself defended itself against these outlier theories like Einstein's. And it wasn't until scientist after scientist after scientist reproved Einstein's ideas on the theories of relativity that science ultimately began to reshape itself. Science becomes vested in its own ideas, and at times it's very hard for science to move. Another example is that in reference to global warming and previous warming periods that looked at how the ice ages ended and how long it took them to end. If you listen much to the ideas and the critiques offered in reference to global warming over time, what you see is most scientists thought that the processes happened over a much longer period. But there were a couple of scientists that said no. They thought that the warming process itself could happen in a matter of 100 or 200 years versus 1,000 years. And so these outlier theories were not given much credence. They weren't taken very seriously. But as science began to look harder and harder at the topics over time, the outlier theories started to gain credence. And we are now seeing scientific predictions in reference to global warming moving away from this idea that it takes 1,000 years and really starting to say this process could happen a lot faster than we thought. Another idea is the idea of the black box. In this case, the nuclear black box. The nuclear black box are the containment structures at Vogtle nuclear reactors 1 and 2 in Burke, Georgia. The box and the complexity and danger of the nuclear reaction processes is what we're really talking about here. So we begin to take the idea of nuclear technology as a given, but we have absolutely no idea how the process works. We just know that we like the power that comes from it. And so when we look at nuclear reactors from a social perspective, we don't really give too much credence into what's going on within the reactors and why it's important to us. All we really care about is that we keep getting the energy. And that in the long run could be a problem for us because it's that stuff that we don't understand. It's that stuff in the black box that could create great harm for us over time. And they use the example of Fukushima and how the assumptions were that the reactors would always be fine, that a tsunami would not create some serious problems for a reactor like Fukushima and really challenge the ability of that nuclear reactor to continue to operate. And then the consequences of the reactors not being able to cool down in the ways that they were designed to, and then how that could create some real problems for society as a whole. Once again, that brings us back to Bruno Latour's actor network theory, or ANT theory, which is a popular method for tracing the mutually constituted relationships between human science and technology. In the ANT theory, things with consequences are the actants. Um, we know actants interact with and through their performances. Um, our understandings of the world are factishes, and the simultaneous creation of knowledge and actor networks is the fabrication. It's how all of these processes, human science and technology, are actants, factishes, and ultimately fabrications. And in the end, these common consequences become what we refer to as a mutual constitution. One way of thinking about this actor network theory is by looking at Darwin. So in Darwin's mind, the four species of Darwin's finches becomes important because according to ant theory, these finches were actants that entered an actor network with Darwin, which ultimately had important consequences for Darwin and for finches. So how Darwin sees finches ultimately interacts in a way that impacts the finches themselves, but it also impacts Darwin. And the last thing to think about here is science and technology, once again, as political acts. And we have to remember that, the science in and of itself sees itself as rational and objective. So it doesn't see itself as being influenced by any particular entity, politics, the individual, society. It's just choosing things to prove or disprove. But a science that's but a science that's political is potentially the best science. It's okay for science to be political. It's okay for science to combine with political agendas. We just need a better conversation than we can have as long as all those black boxes block the way. So much like politics, science needs us to shed light on the black boxes that confuse us. We need to bring to light what is happening in these processes so then we can interact with them in a much more realistic and welcoming way.